This is one of the most powerful rocket engines ever put into mass production. It burns methane and liquid oxygen, produces enormous amounts of thrust, and is designed to be reused again and again. But what makes the Raptor engine truly fascinating isn't just its power, and turns them into an engine capable of sending Starship towards space. So how does SpaceX actually build a Raptor engine? The Raptor is the engine developed by SpaceX for Starship and Super Heavy. Unlike traditional rocket engines, Raptor uses liquid methane and liquid oxygen as propellants. In simple terms, almost all of the propellant passes through turbines before entering the main combustion chamber. This makes the engine extremely efficient, but also incredibly difficult to manufacture. And that's where SpaceX's manufacturing philosophy becomes important. Build fast, simplify the design, automate where possible, and constantly improve the product. Before a Raptor becomes an engine, it starts as hundreds of individual components. These include turbopumps, valves, injectors, pipes, combustion chambers, turbine components, sensors, and countless fasteners. Many of these parts are made from high-performance metals and specialized alloys capable of surviving extreme temperatures and pressures. The first major step is precision manufacturing. Instead of simply cutting metal into shape, manufacturers use computer-controlled machines to remove material with incredible accuracy. A CNC machine can take a block of metal and gradually transform it into a component with extremely precise dimensions. For aerospace hardware, even a small manufacturing error can become a serious problem. That's why every critical component must be inspected before it moves to the next stage. Some components can also be produced using additive manufacturing, commonly known as 3D printing. Instead of removing material from a solid block, additive manufacturing builds a component layer by layer. This can create shapes that would be difficult or even impossible to manufacture using traditional methods. For rocket engines, that can mean fewer parts, simpler assemblies, and faster development. But manufacturing is only half the battle. Every component has to work under extreme conditions. Once the individual components are manufactured and inspected, they have to become a single machine. And a Raptor engine is essentially a collection of extremely complicated systems working together. At the heart of the engine is the combustion chamber. This is where methane and oxygen are ultimately burned to produce the hot, expanding gases that generate thrust. But getting those propellants into the right place requires powerful turbo pumps.
8, 7,
Pumps spin at
6,
extremely
5, 3, 2, 1, 0.
Then there are the injectors.
Liftoff
Their job
of
is to
Space
mix
Shuttle
fuel
and Atlantis
oxidizer
on a mission to build, resupply, and to do
The
research
geometry
on the
inside these
International Space Station.
Houston now controlling. Atlantis begins its penultimate journey to shore up the International Space Station.
This is why the Raptor can't simply be treated like a normal industrial machine. Every connection, seal, weld, and surface has a purpose. Engineers have to control contamination, alignment, tolerances, and material quality. The final engine is assembled from hundreds of parts that must behave as one system. And then comes perhaps the most important part of the entire manufacturing process: testing. A rocket engine can look perfect on the outside and still fail catastrophically under full power. That's why SpaceX relies heavily on testing. A completed engine can be connected to a test stand and pushed toward the limits of its design. Engineers monitor pressure, temperature, vibration, turbopump performance, combustion behavior, and hundreds of other parameters. If something fails, the failure becomes data. A damaged component can reveal where the design needs to change. A temperature spike can expose a cooling problem. A vibration pattern can reveal an issue that wasn't visible during inspection. The goal isn't simply to build one perfect engine. The goal is to create a manufacturing system that gets better with every iteration. This rapid feedback loop is one of SpaceX's biggest manufacturing advantages. Instead of spending years designing an engine and then producing a small number of expensive units, the company is focused on producing engines at a much higher rate. More engines mean more tests. More tests mean more data. More data can lead to better designs. And better designs can make the next generation easier and cheaper to manufacture. It's a cycle. Manufacture, test, learn, redesign, and manufacture again. And this brings us to the bigger picture. Starship isn't designed around launching a single time. The long-term goal is a rapidly reusable transportation system. That means SpaceX needs engines that aren't just powerful, they need to be produced repeatedly, maintained, tested, and eventually flown again. The Raptor therefore represents more than a rocket engine. It represents a manufacturing philosophy. Instead of treating every engine as a unique masterpiece, SpaceX is trying to make rocket engines more like products that can be manufactured at scale. So how does SpaceX manufacture a Raptor engine? It starts with advanced materials and precision machine components. Those components are inspected, assembled into complex propulsion systems, and subjected to extreme testing. When something goes wrong, engineers study the data and improve the design. Then the process starts again. The real innovation isn't just the engine itself. It's the system used to build, test, fail, learn, and build the next one faster. And if SpaceX succeeds in producing Raptor engines at the scale Starship requires, it could fundamentally change the economics of spaceflight. Because getting to space isn't only about building a powerful rocket, it's about learning how to build thousands of powerful machines reliably. And that may be the most important technology SpaceX is developing.